Now this curve here is called a load duration curve. This is comparing 3 different facilities and looking at the difference in the percentage of time that they're at different energy levels. In this case here, there's 3 different meters for 3 different facilities, and we're trying to examine how we can possibly reduce the peak demand. A load duration curve is plotting the percentage of time that a building is operating at certain demand levels. In this case here, for this facility, it has a change in demand from 2800 kW down to approximately 2500 kW. So a 300 kW change in demand about 3% of the time. As compared to this building, or these 2 buildings here, that have about 100 kW change in demand over approximately 14% of the time. So in these cases, if you want to change your peak demand levels, for this facility here, you need to change your operating hours that are at or above these levels for only about 3% of your operating hours. To get a much smaller change in your energy usage, you have to change about 12% of your operating hours. So comparing the difference in these buildings, this building located here in Philadelphia would be a target for one that you can make some significant demand changes by changing your load for only 3% of the time. These facilities here in San Jose and New Orleans would take a lot of change in your load to be able to affect a change in your demand readings. Here's another example of a chart or graph that the software can provide, and this is a calendar summary. Unlike the 24-hour line chart that overlays each day on top of each other, this is set up in a calendar format, so I can quickly look at my Sundays and see how my Sundays line up, see what's happening on my Saturdays, and also see what's happening on a weekly basis. Here's January 1st, which was a holiday, and luckily my building was shut down that day. You can look at the different days of the week and see what's happening at different times with a kind of a thumbnail of your load profile here. Also in these cases, hovering over a certain day will give you the peak value, the total consumption for that day, and also provides the maximum and minimum temperatures. Another useful report is a scorecard type report. In this case, it starts off by giving you a timeline for the day, showing you your low temperature for the day, when you peaked, and your high temperature for the day. It also looks at your electrical consumption and compares what the actual usage was to what was expected based on the weather for yesterday. In this case here, your actual use was higher than your expected use, and so it color-coded this as being a high day or above what was expected for the weather pattern. It gives you again a thumbnail of your load profile, also showing in this darker gray area when your normal operating hours are. The next thing the scorecard report shows you is your potential peak days. So what it's looking for is looking at the next 5-day weather forecast and showing you what days have a higher or lower risk of exceeding a new peak. This is helpful in looking forward to trends. For example, for days the beginning of next week or on weekends, when you find out that over the weekend was supposed to be a really hot day and you need to change possibly what your building startup schedule is going to be like on Monday. The other thing this type of scorecard report allows you to do is put notes or comments that can show up in reports, such as that you needed fans and boilers running 24 hours a day, 7 days a week because the building wasn't able to keep up with low outside temperatures. And you can make notes about how the building is operating during those periods of time. Another monthly calendar profile way of looking at things is through this software that's provided by Energy Lens. This software is an add-in to Excel, so you need to have Microsoft Excel. For the period of time of the data that you have that gets imported into Excel, these graphs here are similar to the previous calendar profile, so it allows you to compare your Sundays with the other days of the week or Sundays with each other, and you can find potential problem areas. In this case here, you can see that this is the lowest minimum profile for a Monday. Here's the average profile, and here's the peak day profile for the period of time you have selected. you can look at these values and see the darker blue area profile that's filled in is the profile for the specific day you're looking at. So in this example, you can look at Tuesday, August 28th, and see that it exceeded the average day for most of the time during this period of time. Same thing with Wednesday. You can see that this is a lot higher energy use than the average. On Monday, August 27th, you can see that the energy usage is quite a bit lower than the average. Some of this information might help you determine, for example, that Monday might have been a day that you've changed a schedule around and you were able to save some energy by reducing the operating set points of your heating and ventilation system. Another useful chart is looking at your monthly usage, in this case on a bar graph that shows the energy usage for each day. On the left side of the graph is showing you kilowatt hours, and that's for the blue bars. On the right hand graph, it's showing you your demand, and in this case it's showing you a minimum demand, the average demand, and the maximum demand for each day. Now, with some of these charts, just like the 24-hour line chart, there seems to be a lot of information here, and you need to start breaking it down. So first of all, let's look at weekends. Here's Tuesday, Wednesday, Thursday, Friday. Here's a Saturday, Sunday. Monday through Friday, Saturday, Sunday. So let's focus on the weekends. So typically, Saturday has a higher peak usage than Sunday does, and also is using more kilowatt hours. In this case here, that's the same for both these weeks. Now this weekend here had a higher peak demand on Sunday and a lot more energy usage. This might key you in to look and try to find out what happened on those 2 days. Why are they not in the same pattern as the rest of them? So this is something you could go and look at and try to find out, looking at the individual days and possibly the weather pattern, and see what happened during that day. Now, all these questions that you come up with, the software isn't going to give you the answers. It's going to take a little bit of research into what happened during that day and finding out if somebody turned something extra on, maybe somebody came in on the weekend, maybe somebody overrides something for some maintenance. Those types of things are things you want to find out. Another day to look at on here is, let's look at the weekdays. You typically see Monday through Friday has a demand, in this case, of about 780 to 800. Well, here's a day here, one day out of the whole month, that gave you a peak up to over 900 kW. If this happened just during this month, that additional cost, if you look at your utility bill, is an extra about 100 kW demand charge. And so depending upon what your demand charges are, typically between $2 and $4 a kW, this could be an additional $200 to $400 a month just because of the operations that happened that one day. Now granted, if it were a really hot day that day, or you needed to run that extra chiller, then you can't let the tenants suffer. But let's say that chiller wasn't needed during that day. Maybe it wasn't a hot day, maybe it was like the rest of them. Hopefully this wasn't just somebody testing a chiller that just came out of maintenance and decided to run it, started it up while the other chillers are running for testing. That type of testing should be done at night while another chiller is off, or if it is run during the day, to start up that chiller after you've already turned the one that was running off. So these are some of the things that you can look at to help determine what's going on with your energy usage over a month's period of time.